Well, hi guys. This is the very last of our complex regions sections, loci spooky complex number. And today we're doing the last of the conic sections, which is the hyperbola, the superbola hyperbola. And here it comes. Hyperbola's everywhere. And look, for this last section, I've put the conic section in for you to have a look at as a little celebration of the beauty and the synchronicity of the conic sections. There it is. Now, just very quickly, if you take a cross-section of a cone horizontally, you get a circle. If you do it at an angle, you get an ellipse. If you do it at an even steeper angle, such that you no longer have an enclosed shape, you get a parabola. And if you do a vertical cut, you get a hyperbola. How superbola is that? And if you had an inverted cone sitting on top of the point here, another one, an inverted cone, connected via this point, the apex, and you did this same vertical cut, here you would get the two branches of the hyperbola. I know, isn't it beautiful? It is. So, righto, here we go. General form of a hyperbola. I've got to get through this because this is a pretty long, detailed session. Now, that's the general form of a hyperbola. H and K is the centre. There. That's HK. In this case, that's on the centre, but it doesn't have to be. If H and K were not zero, that would be off-centre. Yes? Now, that's a left and right one. If the x squared term is positive, that's a left and right one. Okay? Which you'll very quickly arrive at the same conclusion if you basically try and work out some y-intercepts by setting x equal to 0. You won't get any because you'll get an unreal situation. The negative term creates something which is undoable for getting y-intercepts. You see? So, if the x squared is a positive term, it's a left and right one. And A, today, is the distance from the centre horizontally to the vertex. That's what it is. That's what A is, right? Okay, now, B, you're asking me about B. I can hear you. Well, B over A is basically the gradient of the asymptotes. That's what it is. It's the gradient of the asymptotes. And incidentally, for a little extra little snippet of wonderful information for you, if you want to get the asymptotes, you just neglect this 1 and call it a 0. You just give it a cross it out, and you solve the thing for y in terms of x, and you'll get the equations of the asymptotes, and the gradients will be plus or minus b over a after you take the square root of both sides. That's what will happen. Okay, did you get all that? I'm talking pretty fast. Now this one here is the other beastie. This is the up and down one because the y squared is the positive term here, okay? Now everything is the same except that the distance from the centre to the vertex has to go upwards this time, and that is going to be b and not a, okay? B is the distance from the centre to the vertex in the vertical direction, and the same asymptotes, exactly the same asymptotes. Everything's the same apart from that. Okay, and obviously apart from the fact that it's an up and down one as well. Okay? Good, that's what we do there. That's the form of a hyperbola, okay? It's superbola, isn't it? Now, yeah, that's the general form of the locus of the hyperbola. Now, I just want to point out, if this was a plus here, and this was a plus there, now, that would not be a hyperbola, would it? No, it would be an ellipse, right? This is the only difference. And down here with the equation of the locus, this again is the only difference. You have a minus sign in here instead of a plus. If that was a plus, you're potentially looking at an ellipse, okay? That's the general equation in the locus form of a hyperbola. Now, the only other difference, ladies and gentlemen, is that you've got to again do this computation of the distance between this focus and this focus. Okay, now for the ellipse, this number has to be greater, but for the hyperbola, this number has to be less. How do you like the patterns and the order and the magnificent way that maths works? It's just something else, isn't it? It's quite beautiful. And the other thing is we only get one branch of the hyperbola doing this little equation here, and which branch you get depends on which one of these is plus and which one of these is minus. So, yeah, we'll explain that in a moment. But if I reversed these terms and made this one plus and this one minus, you'd get exactly the same hyperbola, but the other branch. Woo! That's pretty amazing, isn't it? Yes, so you only get one branch. We'll go through all that as we go through the session. Okay, so where the distance between C and D has to be more than E for a hyperbola, and whereas for the case of the ellipse it had to be less than, didn't it? Yes. How marvellous. Okay, let's go. Fasten your seatbelts. Here we go. Now I want you to consider, as I'm geometrically, intuitively guiding you along the path of how to understand where the hyperbola comes from, I want you to think of this equation here. Now I've devilishly cunningly disguised something that you already know very well. You'd look at that and you'd go, just as I did. However, if I rewrote it and took the second term over to the right-hand side, you'd go, I know what that is. That's the perpendicular bisector of the line which joins x is 6 and x is 2. Well, indeed it is. It certainly is. So that's what it is, and I've drawn it in there for you. So you can see there's 2 and there's 6, and what we're looking for is that's the perpendicular bisector, isn't it? You're well and truly familiar with that, right? So let me disguise it again. Well, it's not disguised anymore. Put it back in that form, right? So that is the same thing, isn't it, right? That's saying that the distance that z is from 6, take away the distance that z is from 2, is nothing. In other words, they're the same distance. The z is always the same distance from 6 as it is from 2. Now the plot thickens. What about, consider this. If I took that same equation and turned that into an inequation so that the distance from 6 was greater than the distance from 2. In other words, if you subtract the distance from 2 away from the distance from 6, you get a positive number. So it's further from 6 than it is from 2. Do you get that? You've got to get that, you've got to get that. You've got to get it? Yes? Right, locked in? Right. Now what happens, ladies and gentlemen, is as soon as you make that number not a 0 and it starts to build up, trend upwards from 0 to somewhere up to a maximum of the distance between these two foci, you get a hyperbola. You get a hyperbola, okay? And what it'll do, it will start to bend. The more this number is, it starts to move over closer to the one that it's closer to, even closer, and it starts to bend and wrap itself around that with its loving embrace. Oh, yuck. So therefore, yeah, that's right. So what are we saying? We're saying that the distance of z from 6 and 0 is greater than the distance of z from 2 and 0, right? That's a hyperbola as soon as you get that, right? So, now this is the trend. As this expression here, modulus z minus 6, take away modulus z minus 2, in other words, the distance from 6, take away the distance from 2, increases, e.g., it's closer to 2 than it is to 6. It increases from 0 up to a maximum value of the distance between those two foci, which is 4 units in this case. The vertical line moves progressively closer to the ones that it's closer to and wraps itself around it. Look, that's a hyperbola. Isn't it superbola? All right, I'll stop now. There it goes again. Now the number just got bigger. Okay, the number just got bigger. This number here, right? Might have been 1, now it might have gone to 2, now it might go to, now it might go to 3. It looks like it's about 3 there. Now guess what might happen if it actually gets to 4? What do you think it's trending towards doing? Remembering that in the case of the ellipse, when you got to the limiting value of the number on the right-hand side, it collapsed into a straight line between the two foci. Well, it's not going to collapse into a straight line between the two foci, but it is going to collapse into a straight line. And where's that straight line going to be going from and to? Keeping you in suspense. When it gets to 4, the straight line, you get a straight line emanating to the left from x equals 2. And if you just look at the diagram, you'll see me do it. Yeah, that's the equation. Here it comes. Y is 0, but x is less than or equal to 2. There it goes. You see it? It's like a ray going from this point, including this point, and shooting out there to the left, yes? And if you think about this, this is the beautiful thing. If you said this, you said the distance from Z, take away the distance from 2, is equal to 4, well then, it's if you think about this, anywhere along this line, you check it out. The distance from this point here, for example, where that little 1 is annotated, back to 6, back to here, take away the distance from this point to the point 2, well, it has to be 4 units, exactly 4 units, because that's the gap along that same horizontal straight line between 6 and 2. So therefore, that's what happens, right? That's the limiting value. Now, if you make that number here, if you make that number in this case any more than 4, you got yourself a non-solution. You got yourself a non-solution. So that's what I've said there. So if it's more than 4, no solution is possible. Okay? It's just got so many parallels to the ellipse. It's so spooky. It's just beautiful. So there it is. So that's how the hyperbola works, yeah? All right, now we're going to do some examples, I think. Okay, what's this beast? Okay, looks all right. I think that's doable. What's this one? Yes, I think that's doable too. That one looks, yeah. See, what I'm doing, guys, is I'm checking these distances, see, to see whether anybody's trying to trick us. Okay? That's more than that, so that's doable. This one is the same beastie, except that I've reversed the terms and I've made this number bigger, but the distance between 2 and 6 is still more than 3, so we're okay. But this one will be considerably bent over and more wrapped around. And it'll be the other branch of the hyperbola, because I've reversed the terms. Devilishly cunning, aren't I? Now, let's check this one out. We'll do a bit of detective work here. Okay, so this is that's the distance of Z from 8i, that's 8, coordinate 0, 8 on the y-axis. Take away the distance from negative I, remember, Z minus negative I, so that'll be 0 minus 1 on the y-axis, yes, is that right? So that is 9 units, isn't it? And that's more than this number, okay? So that's okay, that's going to be a hyperbola. That'll be an up and down one, though. That'll be an up and down one if you just get your thinking orientated, and it'll still only be one branch. They're all going to be only one branch, right? They're all going to be only one branch. And the reason that I reversed these terms here was to show you that the wheel will get the other branch, and that it'll be considerably hunched over more because we've upped the ante and made the number bigger. Okay? You get me? I think there's a fourth one. Yes, here it comes. Now, I think this is my trickster. Yeah, that's my trickster one. Look, because this distance here between 2 and 6 is 4 units, and I've got exactly 4 units there, so I predict this will be a line emanating from one of the foci and shooting out horizontally, because this is a left and right hyperbola, okay? Left and right one, okay? And this is an up and down one, yeah? Because the foci are on the y, they're orientated vertically in relation to one another. These foci are orientated horizontally in relation to one another, so that's a left and right one. Do you get this? It's very exciting. Now, there's some very heavy algebra to follow, so do you want to pause me, go and get a cup of tea and a goodly supply of chill pills? Yes? All right? I'll wait. Right, you back? Good, let's go. Now, this first one. Right, what are we going to do? Algebra? Oh, give it heavens. Oh, there's my chill pill. Now, but we know how to do it, don't we? We do indeed know how to do it, so let's go for it. Come on. Onward, onward, ever onward. Courage is the key. So we've got to do this. Now, yes, it's a hyperbola because the distance between 2 and 6 is 4 units, and 4 units is more than 2 units, so yes, we're in business. Let's put our ducklings together, get all the... Oh no, I've just X and Y and I Y'd the Z terms. Now we're going to get our ducklings together. And yes, now that's good. Now I'm going to Pythagorate it, I think. Sorry, Pythagoras. He wouldn't mind. So that's that. Now we have to take one term over to the other side, otherwise we're going to end up with an impossible mess. Impossible mess. So there you go, like a good little boy. I've done that. Now, I think we're now safe, well, in a manner of speaking, providing we put ourselves in algebra four-wheel drive mode and don't become algebra heroes. We can square both sides very, very carefully, right? Here we go. Yes. All right. That's all right. Looks all right, doesn't it? Okay, so I think we need to multiply out the brackets now and end up with a huge, enormous sausage machine. Yes, then we're going to clean up. Okay, so what will cancel? Oh, yes, all good. X squareds and Y squareds. Oh, there's a 4 as well, I think. Yes. Well, that's good. There goes the X squareds. There goes the Y squareds. Oh, I didn't do the 4. I didn't see it when I did it. When I did it. All right, that's all right. Now, I've taken the common factor out. I always look for the common factor. And 4 was the common factor, wasn't it? Oh, no, the 4s didn't cancel. What am I talking about? Sorry about that. 4s didn't cancel at all. That's why I didn't cancel them. Now, there's a very important step here, which we don't do in the ellipse, but this is the very important intermission point, okay, which tells us which branch of the hyperbola we've got. Okay, now, the right-hand side, ladies and gentlemen, that's a positive square root term, yes? So that must be greater than or equal to 0, mustn't it? Absolutely it must. So therefore, we're saying that the left-hand side must be also greater than or equal to 0. Yes? This is a very important thing. Now that tells us if we solve that for x, yes, poor little helper, he's already feeling the pinch. Don't worry, little helper, we'll do it together. We'll survive and we'll thrive. So how do we solve that? Now come on, don't fall in the fat. We've got a -2 there. Remember what happens when you divide by -2? Yes, you reverse. You reverse the crocodile mouth, the alligator mouth, yes? It goes to that. So x has got to be less than or equal to 7/2. Now, ladies and gentlemen, that is going to determine which branch, deserves an honorary box, which branch of the hyperbola we're going to get. If it's less than 7/2, I would say it's going to be, if you think about that, less than something, it's probably going to be the left-hand branch. I think so. And it makes sense to me because it's further from 6 as it is from 2, so it's going to wrap itself around the 2. That makes sense, doesn't it? I think so. Okay, now we're going to square both sides. Oh, hang on to your hat. Here we go. All right, so off we go. Yes, agree. And I've multiplied out the right-hand side at the same time to save myself a bit of effort. Now, how are we going? Yes, yes, yes. Got that? Okay, so it looks like we have to complete the square with the x business, but not the y, because the x has a middle term. So, all right, that's good. Now, oh, I already did it. I was about to tell you what we needed. So you have the 8, and then you square it, and then you take away that number straight away. Now, in the next line, we have to get that second number out of there, because he's not part of our completed square quadratic trinomial, is he? But you have to remember to multiply him by 3. Otherwise, you will be in the ditch. When we don't want that. That's good. I did it. I did everything good. Didn't I? I did everything well, I mean. Right. Now, that's looking pretty good. Oh, I think we're nearly finished, actually. Just clean up a little bit. Yeah. Oh, good gracious me. How beautiful. Divide both sides by 3. What do I get? How marvellous. I think it deserves a box. Thank you, Mr. Box. Okay, so that is our hyperbola. That is our hyperbola, okay? So, and we've got this thing here defined here. We know which branch we're dealing with as long as we can get that thing in place, okay? So what do we know? We know that A is that's the a term. It's just over 1. So a squared is 1. So a is 1. So therefore, the centre of this thing is at 4 and 0, and we're saying that it's 1 unit to go from the centre to the vertex of the hyperbola, okay? Yes, that's what we're saying, because a is 1, right? And if it's a left-hand branch, it's got to be 1 unit to the left of the centre point, which would be at 3, where x is 3, wouldn't it? Let's see if that all works out. Okay, for sketching purposes, we need all the jolly intercepts and everything else all over the place, and the equations of the asymptotes, so we better do it, okay? Right, the intercepts, here we go. Now, there's no y-intercepts for this, so are there? Wait a minute, it's not on the centre, is it? I'll reserve judgment for a minute. Okay, so what am I saying? Yes, I put y as 0, solving for that. Therefore, if yes, x equals 3, yes, good. And we're saying, if it's plus 1, x is 5. Now, okay, so what was I saying? Look at this. We're saying x has to be less than or equal to 3.5. So, therefore, you're in like Flynn, you're persona non grata. We don't want you because you're part of the right-hand branch, which does not apply. So, goodbye. And you can fly away. There you go. That's it. See? So it was as I predicted. You see, A was 1, and it went 1 left of the centre point of the hyperbola and made our x-intercept 3 and 0. Isn't that nice? Now, when x is 0, yes, we're going for y-intercepts, which, if I think about it, I think we're going to get some now, because it's off-centre, okay? Yes, there you go. There you go. So let's see. Now, therefore, y squared is at 45. Aha! Therefore, yes, don't worry, little fellow. Just have an aspirin or something. Go and have a lie down. We can do without you for a while. So therefore, y is plus or minus 3 root 5, and we get that in formal terms as coordinate points. Very good. Now, that's excellent. Okay, so therefore, yes, and for graphing purposes, it's approximately, I worked it out, 6.7. So there you go. Now, have we got everything? No, we need our jolly asymptotes now. The hyperbola, that might be superbola, but it's a lot of work. So, there we go. Now, let's do our asymptotes. Neglect the 1. We chuck the 1 out. Goodbye, Mr. 1. Only for the asymptotes. So don't get all stirred up. It's only for the asymptotes, because they're not actually the equation of the hyperbola. They're just the asymptotes. That's why we chuck it out, because it becomes increasingly insignificant as the hyperbola zooms off into outer cyberspace, and that's the actual asymptote is when one actually isn't there, has no presence. That's why you do it. Okay, so what have we got? We've got y is going to be plus or minus root 3x minus 4, and there it is. So there's our asymptotes. The gradient, okay, is that, and that will be plus or minus b over a, won't it? And yes, it is, because b is 3, or b squared is 3, therefore b is root 3, a is 1. So it's all coming true for me and you. That is plus or minus root 3 is plus or minus b over a, right? Good. There, another box, honorary box. So that's for the asymptotes. Now, what else? Good heavens, there can't be any more. Oh, for the sake of graphing proportion, I'm actually thinking I need to get the intercepts of the asymptotes. Yeah, is that right? What have I done there? When x is 0, yeah, oh yes. Okay, that's all right, but you don't need to actually state the intercepts of the asymptotes. Don't do that. You just need to sort of know where they go just to get the proportions of the graph all looking correct, okay? You do have to state the intercepts of the hyperbola itself. Now, here it is, everybody. Let's look at this. Okay, so what have I got here? There's my centre. Yeah, oh, everything's happening at once here. Wait a minute. Right, so what have I done? I've got the centre there. I've got, that's one of my asymptotes. That's the y equals minus root 3x minus 4. This one up here is the plus root 3x minus 4. This is the intercept. Okay, that's the x-intercept. And these are my y-intercepts here and here. But, ladies and gentlemen, it's only one branch. So that's the point where x equals... yes, so that's the point we're concerned about. And it's 7 over 2, or 3.5. So we knew that x had to be less than or equal to this point here. So the only branch of the hyperbola which qualifies there, ladies and gentlemen, is this branch. So this branch here is persona non grata. I'm sorry, but you have to go, don't you know? There you go, I'm crossing him out as we speak. Sad, isn't it? So therefore we have the left branch only, and that's our solution. Okay? Got it? Excellent. Now we're going to do the geometric way. Now you just watch how beautiful this is. It's just the most simplistic, lovely, elegant, delightful method you've ever seen in your life, compared to the sludge which we go through with the algebra. Now, okay, so let's go with this. What have I got here? I've got z minus, modulus z minus 6 minus modulus of z minus 2 equals 2. Okay, so therefore the first thing I'm noticing is, because this is a left and right hyperbola, because these guys here are horizontally orientated towards each other, the line between them is a horizontal line, if you like. Therefore, the first thing you notice is that this here, a, is half of this number. Half of this number, so therefore a is going to be 1. You can just read that and take it to the bank. Okay, that's the first thing. Similar to the ellipse, where we're saying for the ellipse that this number was half the semi-axis upon which the foci reside. Well, this number here is half the distance from the centre of the hyperbola to the vertex. Okay, to the vertex, and the vertex. In this case will be a horizontal distance, right, from the centre to the vertex, because it's a left and right hyperbola, right, superbola, right? Now that's 1, right? Now that's the next thing. Now, okay, so the centre, okay, the centre is halfway between 2, 0 and 6, 0, which is going to be at 4, 0. Okay, well, goodness, we're nearly there. All we've got to do now is get B sorted out for you and me, and we're done. We've got A, we've got the centre point, okay? So, here we go. Now, yeah, now I've written it in this form, just to get, we've got to get some geometrical perspective happening here in order to find B. So look, we're saying that Z minus 6, modulus Z minus 6 is equal to the modulus of Z minus 2 plus 2. Just to really drive the point home that this one is further, okay? The distance from this point here is further than the distance from this point here, of any point Z on the locus, okay? It's 2 units further from 6 as it is from 2, okay? So therefore, what are we going to do? We're saying that therefore the distance of Z from 6, 0, coordinate point is 2 more than the distance of Z from coordinate point 2, 0, right? Now, therefore this is the crucial bit. Therefore the hyperbola bends away from 6, the one that's further from, and towards the one that it's closer to, and wraps itself around the 2. Now that's how to get your geometrical perspective. Therefore the vertex is 1 unit left of centre. Do you get that? 1 unit left of centre, because A is 1, and A is the distance from the centre to the vertex, okay? And it's wrapping itself around towards the 2, so it's moving to the left. That's the point, okay? There it is. That's our orientation throughout the nation, if you get that. Yes? That's very important to get that, okay? Right, now, we have this form of our hyperbola, and the only thing we haven't got is the B term, which we're now going to do a bit of geometry, including a Pythagorean magic trick, to get the B for you and me, okay? Now you watch how we do this. It's rather beautiful. So B is the only thing we don't know about this hyperbola, the only thing left to find, okay? Now, we use the locus equation and some Pythagorean magic to get this. Okay, over the page we go. Now, all right, so that's where we got to, right? Now, watch this. Now, what I'm doing is I'm drawing watch this, I'm drawing a line from one focus down to the focus, which is having the locus, the hyperbola branch wrapping around it, and then I go perpendicularly out to it, to meet it, to greet it, okay? And where it hits it, where it intersects with it, I then draw a straight line of sight back to the focus where I started from, right? Now, the reason I'm doing this is because if you have a look at this point here is going to be 2 and some value y, which is what I want to find here. That's my objective, okay? Now, that distance there is going to be y, isn't it? It's vertical from where y is 0 to where y is whatever it is. Now, what's this distance here? What's this hypotenuse distance going to be? Look at your locus equation, okay? That's my clue, okay? Yeah, I'm drawing it up in a little bit larger form up here so you can actually see what we're doing, because this is all a bit too minute. Now, okay, so that's 4. The BC is 4, AB is y, and yeah, AC has to be 2 plus y because it's 2 units further from any point on the locus of the hyperbola to get back to that focus as it is to get back to this one. So if this one is y, this one here must be 2 more, because that's what the whole thing says. Now that's pretty brilliant, isn't it? Now let's do some Pythagorean magic here. Yes, we know that. What else have I written there? We want to find y at A. That's what we want to find. Because once we can find y at A, then we've got x and y at A, which we will substitute into our equation, and B will be ours for the taking. Okay? That's why we do it. Okay, so let's just solve this little equation here. That's Pythagoras' theorem in triangle ABC. Now, I'm getting too excited here. Is this right? 4 plus 4y plus y squared equals y squared plus 16. Yes. Cancel. And what do we get? 4y is 12, therefore y... Oh, how beautiful. Y is 3 for you and me. So we sub x is 2 and y is 3. That's this point. Now, just to get perfectly clear, that's this point here, right? Y is 3. We substitute that into the equation of a hyperbola because we now have a known point on the hyperbola, and B is the only unknown. We can find B. We can find B. That's what it is. Once we've got B, where it's all over Red Rover, we've done it. Okay? There goes the X subbed in. There goes the Y subbed in, and we're just going to solve it for B now. Make sure we don't make a mistake. That looks right. Now, okay, right, so up there, I'm up here now, so what have I got? Okay, that looks good, therefore 3b's, what have I got there? Minus 3b squared is minus 9, yeah, that's alright, that's just cross multiplying, therefore it looks like b squared equals 3. My goodness, fills us with glee for you and me, that's the answer, and therefore we have our hyperbola. Yes, there it is, that's it, and it's the left-hand branch only, as we discovered, There it is, okay? You'll probably need to put in there something like, oh no, that'll do, left-hand branch only, that'll do. So that's the thing. Now, of course, if you, any remaining fiddling around, like as we did before to get intercepts and asymptotes and all the rest of it, you can do that. Once you've got your equation, you can do that. It's just a piece of cake. Yes, which is a pleasure to make, the piece of cake, as we've just done. All right? Now, that is the geometrical procedure for getting a hyperbola, which is a very, very superbola. Okay, what have I said here? NB. Oh, yes, this is a very fascinating point. Now, you see what we got up here, ladies and gentlemen. That's the equation of the hyperbola of the left-hand branch of the hyperbola, which we've just determined. If you had the terms reversed, like I've got here, same thing but terms reversed, this is plus and this is minus, you would get the same hyperbola except you get the right-hand branch. The right-hand branch. Isn't it amazing? The pattern is beautiful. All right, so now, what's this? Now, I think we're up to something else now. Probably B for you and me. All right, so this is looks like the same thing, except, as I've just been explaining, it's going to be the right-hand branch and it'll be considerably more scrunched over. All right, so I don't want to do algebraic. Do you mind? I'm just fed up with algebraic. Let's do some geometric. It's so much easier. Easy peasy. Yeah, that's good. Now, we know that because this is a left-right one, it's a left-right one because these guys are orientated in a horizontal fashion from each other. These guys, 2 and 6, okay, they're 4 apart horizontally, therefore it's a left-right one. All right? A is, in this case, A is going to be 3 over 2, it's half of this, and the centre is going to be 4 and 0 because it's halfway between here and here. All right? Now, okay, so Z is further from 2 on this occasion than it is from 6, okay? It's further from 2, so it's going to bend itself around the 6 focus. Yes, that's what it's going to do. Therefore, it is the right-hand branch. All right? Yes? There it goes. Now, where are we? Yes. And I just want to throw in for good measure here, guys. You don't really need to know how to do this, not at all. You just need to know how to recognise a hyperbola. I'm just giving you more information than you need so that you can gain confidence and then pull back into recognition mode for the exam purposes, okay? I'll be a monkey's uncle if I ever make you do any of this. I've never seen it and I'm never expecting it, okay? So I'm really giving you more than you need, but that's all right. It's good for your confidence and it's good for your practice when you do all this stuff. It's all good for your maths. It makes those neurons just fire away in your brain and sing a beautiful song. Okay, so the vertex. The vertex is 3 over 2 units to the right of the centre, okay? So that would be 5.5, wouldn't it? Yes, it would be 5.5. Excellent, because the centre was at 4. So therefore, this is also the... Oh yeah, it's the x-intercept because this one is not... the centre is not displaced vertically above the x-axis. So therefore, it would also be the x-intercept, all right? Okay, so we've got... Automatically, we've got this. Okay, I've drawn the thing in to give you some perspective. And I've drawn the equation with everything we've got there, everything except the B, and we just got to work out the B for you and me. Here it comes. Here comes a lovely diagram for you. There it is. Yes. Good. That looks very mighty fine to me. Right. Now, what have we got here? We've got 4 units between 2 and 6. We've drawn the line from this focus to the other focus, and we've gone immediately perpendicularly out to the curve of the hyperbola, to the right-hand branch, and then we obviously recognise if that distance there is y, because it's 3 units further to get back to the other focus, that must be y plus 3, and we're about to do Pythagoras' theorem, and we get this, we're going to solve it for y, and that looks good, and they cancel out. So therefore 6y has to be equal to 7, and therefore y has to be 7 over 6. Okay, that's 7 over 6. So this point here is x is 6 and y is 7 over 6, which we substitute into the equation to get B for you and me. There it goes. Oh yes, we have to, we have to square that thing. 7 over 6, which gets us 49 over 36. Oh, this is all looking pretty bad. So go carefully, my sons and daughters, lest ye fall in the mud. Now, that's going well, isn't it? Yeah, looks right, good. So, what have I done there? Oh, yes, I've just relegated this to the other side and put it, and then multiplied both sides by -1. Yeah, to get plus. Yes, all right. It looks pretty awful. Now, oh no, it's looking lovely now. Some cancelling is going to happen. 9 goes into 36 4 times, 7 goes into 49 7 times, so we've got 7 over 4. So B squared is 7 over 4. Yes, we see the light. We see the light, and it's very bright. So, therefore, there is our hyperbola. It's the right-hand branch, all right? Now, isn't that beautiful? Thank you, Mr. Box. It is truly marvellous. Now the asymptotes, alright, the asymptotes are, if you neglect the 1, that's what it'll come out to be. I just saved you a bit of trouble there. Okay, so if you make that thing 0 for the asymptote, solve it for y, you're going to get that, right? Yes, yes. Oh, good gracious me, what a mess. Now look, don't worry, it's alright. I drew it this way because this is, oh look, I better explain as I go. This one here is the one we've just done. Okay, that's the one we've just done. That's the right-hand branch of the one we've just done. See how hunched over it is? It's got a bad back, this one. And this one here, this blue one, is the left-hand branch of the one we did previously. Okay, that's what that one is. Yeah. Okay, that was the left-hand branch. So we're saying that was the first one we did. The z minus 6 modulus minus z minus 2 modulus equals 2. This one here is the terms reversed, where the z minus 2 modulus is plus and the z minus 6 modulus is negative, and they're equal to 3. And see, this one moved over 1 from the 4 and wrapped itself around. This blue curve here wraps itself around towards the 2. This one here moved from 4 to 5.5, a little bit further, and wrapped itself around a lot more. Okay? It's getting a very distinctly bad chiropractic condition. Okay? So there it is, okay? That was just to show you that. Sorry for the very, very busy diagram, but you do get the idea, don't you? Yes, you do. Of course you do. Okay, C. All right, C. That looks like a vertical one. Can we please go geometric? Yes. Thank you. Thank you so much. Right. Let's go. Let's go. Don't you know? Okay, so what we're saying here is the distance of Z from 8 on the y-axis. Take away the distance of Z from minus 1 on the y-axis is equal to 6 units. Now the first thing we need to check out is what's this distance. Okay, from plus 8 to minus 1 is 9 units, and 9 units is more than 6 units, so thumbs up, checkaroonie, it is an ellipse, not an ellipse, you silly boy, it's a hyperbola, and it's a hyperbola, and that works. So, and now what's the centre point? Okay, add these 2 points up, divide by 2, so 8 take away 1 is 7, 7 divided by 2 is 7 over 2, so it's, okay, 3.5 units up the y-axis from the origin, and B, seeing that these points here are vertically aligned, we know that this point here is twice the distance from the centre point of the hyperbola up to the vertex, which is up and down. Maybe it's the down vertex. Wait a minute, I've got to establish that yet. From the centre to the vertex anyway. Now wait a minute, so if it's further from the upper point than it is from the lower point, yes, it's going to wrap itself around the lower point. So we would be dealing with the lower branch. So this distance here is the distance from the centre downwards to the vertex of the lower branch. Yeah. Okay, so I think I've just jumped the gun there, told you everything before I wrote it on the screen. Yeah, so it's further from 0 and 8 than it is from 0 and minus 1, therefore it bends around the lower vertex. Okay, it's the lower branch. And the vertex is 3 units. It's actually, wait a minute, the vertex is 3 units, yes, below the centre at this point here. So 3.5 minus 3 is a half, okay? There it is, yes, that's the vertex. Okay, so this basically, this is also the y-intercept because there's no, the centre is still, of this hyperbola is still on the y-axis, okay? It isn't displaced horizontally left or right. So that's good, we've got that. Now, I think we've nearly got everything we need, don't we? We're drawing a diagram now to do our Pythagorean magic, okay? There it goes now. So let's just take all that in. So, yeah, we're going to do a Pythagorean situation here and just see whether oh gee, it's pretty small. There's the equation that we've got so far. We haven't got A. In this case, we haven't got A. We've got B, but, okay, so what do we have? We've got this, okay, we draw the line from this focus here. this 8, down to the -1, which is 9 units long. Then we go perpendicularly out to meet the curve. Hello, curve. Then we draw the hypotenuse back to the original focus. So this one here is 9 units long. This one here we're just going to call x because that's what we want to find. This one here will have to be x plus 6 because this is 6 units more than this one here from this focus to the point on the curve. Okay, so it looks all right to me. Right, let's go. By Pythagoras' theorem, what are we going to get here, guys? Okay. Right, yes. Right, we're going to get that, aren't we? Is that right? Yeah, 9 squared plus x squared equals x plus 6 all squared. Yes, let's hurry up and do this because we're getting into we've already been going 45 minutes, so this will be a 50-minute crackerjack session, I think, by the time we're finished. Okay, yes, x squareds cancel, good. So what's x? Right, is that 45, is it? Yes, so therefore x is going to be 45 over 12, and I can smell a 3 cancelling there. 4 and 15, so it's 15 over 4. X is 15 over 4 at this point here. Okay, so it's going to be minus, no, it's going to be 15 over 4, x is going to be, and y is going to be -1, which is the same coordinate as this point here, because it's horizontally across from there. Okay, so let's sub that into the thing. Yeah, good, into the equation to work out A for us today. Hooray. And we'll have it then. We'll have our hyperbola, our superbola, superbola hyperbola. Is that all right? Goodness, I'm going pretty fast here. Yeah, 9 squared over 4, and there's already a 9 over here, down here, so it's just 9 over 4. That's all right. 15 squared is 225. 4 squared is 16. Yeah, that's all right. Now we're just going to have to get this over there. I think we're going to go over the page. Yeah, we got to there, didn't we? Okay, so, yeah, I've taken that. Yeah, I've done that. Now we just have to cross multiply and solve it for A. That's right. Yes, looks pretty horrible, doesn't it? Gurky. All right, so what's A squared? Oh, good. Oh, mercifully, there's some cancelling going to happen. 5 goes into the 225, 4 goes into the 16. And yes, so we're looking at 45 over 4. So that's what A squared is 45 over 4. So that's what A is today. And we will put that into the equation. I've put it in that form. And that's the lower branch of the hyperbola. Mr. Box, are we ever glad to see you? Goodness, we thought you'd never get here. Right. Oh, phew. Okay, well that's done, guys. We did C for you and me. Now, we got more. How annoying. I suppose we have to do this because we're going to show you the graph in a minute. So you neglect the 1 and you get the asymptotes of that. And that's what it comes to, guys. That's what it comes to. Just believe me at the moment. And there it is, an honorary box. And now the intercepts. Oh, goodness, it never ends. So when y is 0, we solve for x. Now, I've just done it for you quickly because it's all just getting a bit ridiculous, okay? X gets to that. And that's very close to 2. Amazingly close to 2, would you believe? And when x is 0, y is a half, as found earlier, because it was the lower branch of the hyperbola, wasn't it? Yes, good. So I think we're almost ready. Oh, please, let us be ready to go. Oh, excellent. There's the centre. There's the lower branch. There's those stunningly close to 2, plus and minus 2 x-intercepts. There's our lower branch. There's our lower branch. And what else have I got? Crossed out the upper branch. That's that's the positive gradient asymptote. This is the negative gradient asymptote. This is the lower branch. Crossed him out. Better luck next time, upper branch. And what do we got? Yeah, we've done it. We did it. Now, here's the last one. I'm desperately sorry to tell you we're going to go algebraic here. Gurk. Because we're expecting a straight line, aren't we? Look, it's This is the further one. It's further from here than it is from here. So we're expecting a straight line emanating from 2 to the left. That's what we're expecting. Now let's see if we actually get that with algebra. Okay, so what we're saying is the distance between 2 and 6 is 4 units. Right hand side number is 4. Therefore we are expecting a straight line where x goes from 2 to the left and equals 2 and to the left of 2 or less than 2. That's what I'm saying. So here we go, algebraic. And this is the end then. This is a marathon session. Right, I knew it would be. Therefore, there comes the, yes, I've turned the z's into x plus iys. And now I'm going to put the ducklings together and Pythagor. Oh, the ducklings are already together. That's right, in the previous line, sorry. And, okay, squaring both sides. Yes, and what do I get? This has got to come out very simple. We don't want any trauma, please, because it's going to be a straight line. Good. Oh, goodness gracious. Look at that intimidating looking sausage machine. Goodbye x squareds. Goodbye y squareds. Anything else? No, I don't think so. So therefore, what do we get? Mop up. Minus 8x plus 16s plus 8. Common factor of 8. Yes, yes. Let's not be late. Otherwise they'll shut the gate. And we get this. Good. Oh, that's looking rather nice. Let's what have I said there? Oh, yes, I'm going through all this baloney here to work out the branch of the hyperbola, which isn't a hyperbola anyway, but we still need to do this. See all that stuff there, that right-hand side? That's a negative of a positive square root, so therefore that has to be less than or equal to 0, doesn't it? Because it's negative. Therefore, we're saying x minus 2 has to be less than or equal to 0, therefore x has to be less than or equal to 2. That's what determines what's going on here. You do need that step. Let's square both sides now. And what do we get? Oh, look, mercifully it's working out, guys. Look. Now, guess what I'm going to do now? You guessed it. Therefore, y equals 0 and x is less than or equal to 2, which is exactly what we said it was going to be. Exactly what we expected. Okay? Isn't that beautiful? Yes! And we saw the light, and we fought the good fight, and we're right, and my goodness, we're going to get out of here because it's been going for 52 minutes. It was a marathon. Just remember, the overwhelming majority of what I showed you here you don't need to do. You just need to know how to recognise a hyperbola, okay? And by now, my goodness, you will be recognising a hyperbola when you see them, okay? All right, thanks for sticking with me. Such a long session. Farewell, complex numbers. It was really a fun time. I hope you enjoyed it and I hope you got something out of it. You've got to do plenty of practice now and we'll see you when we do another topic. Okay? All the best and we'll see you. Bye.